Okay, continuing our talk about the normal curve, we're to some applications now on the third page. So if you look with me, you'll see our question is, if chicken eggs are normally distributed with a mean of 1.6 ounces and a standard deviation of 0.4 ounces. So that means on average, a normal chicken egg weighs 1.6 ounces. So that's our mean. You know, I like to draw this little curve to kind of demonstrate. So if we were looking at the normal curve, they're normally distributed. You know, most of the eggs fall within the hump there, and then there's some really big or some really small outliers. But the normal mean egg right down the center is 1.6 ounce. And then one standard deviation above would be plus 0.4 ounces, you know, over here. So if z equals 1, we go 1 above, we add the 0.4 ounces it says, and then 1 below. They usually don't make us kind of write it out like that. They just tell us add 1 standard deviation or whatever, and then use the chart. All right, so here's what we're doing. It says find the percent of chicken eggs that are lighter than 1. So that should calculate out to be negative 0.25, but check it on yours as well. So then you look that up as a z-score. That's how we convert something to a z-score. Then we look that up on our chart, and on your table you should get, and I'll just demonstrate that for you again. If we look at negative 1.25, here's can you see that? Not yet. Okay. Go a little bit further and pull this back. Okay, here it is. Negative 0.02, and then that's 0, 1, 2, 3, 4, 5. There it is, 0.4013. So that's where I'm getting that value. That's how we convert it into our percent of data to the left on the curve. So when we look that up and we get our 0.4013, that means that's about 40% of the data will be below that 1.5 ounces. You know, if it was at z equals 0, then we'd be at 50%. It's a 50-50 straight down the middle. Okay, next, so the answer to that is the 40.13% of the chicken eggs should be lighter than, lighter or less than to the left of 1.5 ounces. All right, so an activity is always practice these and then come back into the video, but find the percent that's lighter than 1.6. So 1.6 is a raw score, so we convert it to a z-score by our little formula. The question we're asked, that's the x value minus the mean divided by the standard deviation. Notice 1.6 is exactly on the center. So that's 0 divided by 0.4, which is 0. So if you look at z equals 0, you get a 0.500, because that's right down the center at the 50% mark. When you come right down the center of the curve, 50% is below, 50% above. So that makes sense. That would be 50%. Okay, number 7, the percent that's lighter than 1.4. So we're going to do our calculation. 1.4 is our raw data minus our mean divided by our standard deviation. When you calculate that, you should get a negative 0.5. Then you use that table of values. You look that up. That's your z-score. Once you do this, you've found your z value. Then you can use your table, and it says 0.3085. So lighter than means to the left of, just like the chart gives us. So as long as we're doing a less than question, if we're doing less than, you can notice I kind of bold-faced that to say when we're doing less than, that's exactly what this curve does. It tells you the data that falls below your z-score, or to the left of, or less than whatever you find as z. So when we're looking at z equals 1.4, then that would be the percent to the left of, the less than. 30.85% of the eggs should be lighter than 1.4 ounces. But what if I said, well, how many are heavier than? That's the next thing. If you ask the opposite question, the heavier than or the greater than would be the opposite side of the curve, which we have just one extra step to do, right? You might be thinking in your head already, how if 30%, let's just call it 30, if 30% are less than 1.4 ounces, then 70% would be heavier, right? So it's just a matter of subtracting it from 100% to see the opposite side. So that's what we're going to find out when you, but watch this in your homework. If they ask you a more than question, you've got to remember you've got to do that next step and subtract it from 100%. Or if it's a decimal, you subtract it from 1. 1 is 100% as a decimal. So we have an extra step here. So when you're doing a more than, if you want the percent heavier than 1.5 ounce, for example, then we must subtract from 100%. The entire area of the curve, under the curve, remember, is 100%. If we go from tail end to tail end, that means 100% of the data. So 100% is the whole curve. So we must use our z-table values and subtract from 1 if it's not converted to percent, or from 100% if it's in a percent form, whichever way you have it. So for example, that would mean in our example up here with the 1.5 ounces, 1.5, we did that earlier. Where is that? 1.5 was the 40.13%, right? When we did 1.5 ounces earlier. So if we were doing 1.5 ounces and we wanted to know, and it kind of helps me to draw out my picture and say, here's the middle. Where was the middle? It's 1.6 ounces. So if we're at 1.5 ounces, that's below there a little bit. And if I want to know what's above that, how many eggs weigh more than, the z-score table in our book only gives me to the left end. It gives me this value, which was 0.4013. 40% basically. So this side should be about 60%. But to be exact, we take 1.00, which would be 100% as a decimal, minus our 0.4013. You can do that on your calculator and you get 0.5987, which would be almost 60%, right? 59.87% if it's asked in percent form. So be careful of those when they say more than. So you have an activity, find the percent heavier than 1.6 and then heavier than 1.4. So sort of repeating what we did earlier, we've already looked up that 1.6 ounces and we found that's right down the middle, that's at 50%. So heavier than 50%, when we look that up, there's Z is 1.6. The table tells us 50% less than, but this is a symmetrical curve, so it'll be 50% on the other side too. So 50% is that first question. But what about 1.4 ounces? 1.4 ounces, we did that earlier. 1.4, we looked up its z value, 1.4 minus the mean over standard deviation. That converts it to a z-score and found that to be negative 0.5 z. Then we look that up on our chart and it gives us, where was that? Where am I? 1.4. Yeah, it gives us 0.3085. 0.3085. So that means less than the amount that's less than to the left of. So we need the opposite, 0.5, a z-score negative 0.5, then 30.85% to the left of. So we want this side, we want greater than, heavier than would be greater than. So we have to do 1.000, subtract our 0.3085. And that is, I had that written down so I would have that quicker for you. 0.6915. Or as a percent, 69.15% for that answer. So when you're doing a more than, you're always going to be subtracting what you normally would have done, subtract it from 1 or subtract it from 100% as a final step there. All right. Finally, a between question, and then we'll have covered all of our bases here. So what if they ask you between 1.4 ounces and 1.6? So again, back to our eggs here. We know from our figuring, our earlier same example, that the mean right down the center, that's the 1.6 ounces, right straight down the center. The average weight of an egg in this example is 1.6 ounces. So what if we want to know how many weigh between 1.4, which would be a little less to the left of that then, between 1.4 and 1.6? A between question, that little section there. Now nothing in your z-table chart gives you a between value straight up. All your chart's ever going to give you is the less than value. So it goes from here all the way to the end. But we can do that. We can look up 1.6 all the way to the end, and we've done that earlier, and that gave us 0.5 when we converted it. Then we can look up 1.4, and it'll give us all the way to the end. So there's an overlap. Oh, let me draw this better. So let's say here is z equals 0, right down the center, and then we look at 50%. It gives us 50% when we do 1.6 equals 50%. Then when we look up 1.4 ounces, that's z equals negative 0.5. When we look up that value, it goes from there to the end. So it's double counting. Can you see that? I shaded twice. I shaded from here all the way over, then I shaded from here all the way over. So I've double counted this tail end. So to find the between, we get rid of that part, we subtract that off of our answer. So we find 1.6 is 0.5000 on our z-table. Then we find that 1.4 ounces gave us an answer of 0.3085 for a z-value. So then to get rid of this double counting thing, anytime you do a between problem, you subtract your two answers. Just remember, you just have to subtract your two values that you get from the chart. So all of this, you kind of do the same way. You find your z-value by converting it to a z-score, the raw data minus the mean over the standard deviation. That makes it a z-score. Then you look up that value in your chart. If there's two parts to it, you know, like this one has a 1.4 and a 1.6, we have to do it twice, but I just already done it above there. But we look up those two answers. If it says between, we subtract our two answers, and that gives me 0.1915, or 19.15% of the eggs should weigh between 1.4 and 1.6 ounces. That tells you the between amount when I subtract. Again, to do the more than, you subtract from 1. If it's a less than, that's your best ones, right? If it's less than, that's exactly the way the chart's laid out. It gives you to the left of z-value, which is less than. All right, one more page, I guess one and a little bit more. Just some practice problems now. That's all of the concepts to tell you. Now you just have some problems to practice. So do pause the video because it's real important you get your practice time in and work on this. All right, so determine the area of the curve to the left of negative 1.0. So we look that value up on our z-table. If it says to the left of, you're done. Left of is as stated in the chart, so we don't do anything. So another left of, look up 1.19, straight up look that up in the chart. It gives you 0.8830. So you're done, boom, the answer. But when we do to a right of, we'll have to do the follow-up. And when we do between, we have more work. All right, so to the right of, once we look up 1.19, which, you know, I kind of already did that, you get that answer. Then you have to do 1.00, or just 1 minus in your calculator. I guess it's 1.0000 if you wanted to see it on paper. But you'll do 1 minus that answer. And that is what? I can do that for you real quick. That gives us 0.17, or about 11%. Do it again, 2.34 in your chart gives you 0.9906, but we're doing to the right of, so that means 1 minus that answer. So 1 minus 0.9906 is 0.0094. As a percent, if asked, would be less than 1%, you know, because you're pretty far over there. You're over to those anomalies, the extremes. Okay, between, we have to look up each one of these answers and then subtract those two. So in case I don't get it all done in the video, each one of those will be worked. 1.62 is negative. You see my little negative sign there, is 0.0526. Then we look up 2.57. and that is 0.9949. We subtract those two. I probably should put that in front. So in your calculator, subtract in the order that'll have the largest in front, so your answer will come out correctly. So 0.9423. And then we do the same thing for this one. I'll come back in, finish that up in the next video.